You know when you're chatting with an AI and the words just appear? It feels like magic, almost instantaneous. But what's really going on under the hood to make that speed possible? Well, it's a colossal engineering challenge. So let's dive in and uncover the hidden cost of all that AI speed.
And just to give you an idea of the sheer scale we're dealing with, get this. OpenAI is cranking out something like 100 billion words every single day. That is a truly mind-boggling amount of text, and every single one of those words has to be calculated. So that's the real question, isn't it? What does it actually cost, in terms of energy, time, and engineering, to generate each one of those billions of words? In this explainer, we are going to pull back the curtain on the massive and usually invisible price of AI's incredible velocity.
Okay, so to understand this cost, we have to split the AI world into two very different parts. You've got training, that's the huge, expensive, one-time job of building the AI model in the first place. But then you have inference. That's the cost of actually using the model. Every time you ask it a question, every time it generates a word, and that cost never stops.
Now here's where it gets really interesting. Training and inference are fundamentally different beasts. During training, the AI can look at a whole library of books all at once. It's a massive parallel task, so it's all about raw compute power. But inference, actually talking to the AI, is sequential. It has to come up with one word, then the next, then the next. And that creates a totally different bottleneck. It's not limited by how smart the GPU is, but by how fast it can access its own memory. And this leads us directly to the heart of the problem, the generation bottleneck. That super powerful, expensive AI you're using, it spends most of its time just waiting. It's not slow because the thinking is hard. It's slow because it's constantly waiting for data to be fetched from its memory, just so it can figure out what the very next word should be.
So what exactly is it waiting for? It's waiting for something called the KV cache. The best way to think about this is as the AI's short-term memory. It's where it stores the entire context of your conversation so it knows what you're talking about. It's absolutely essential. But, and this is a big but, this cache is enormous, it's a resource hog, and accessing it is what's causing the traffic jam.
And if we zoom in even closer, this is where the problem really lives. Inside the AI, some parts, called MLP layers, are actually team players. They get more efficient as more people use the system because everyone shares the same core data. But the attention layers, the ones that use that big KV cache we just talked about, are the total opposite. They get worse. Why? Because every single user needs their own separate giant short-term memory cache. So more users doesn't create efficiency, it just creates more and more memory gridlock.
So, how on earth do you solve a problem like that? Well, the most straightforward approach is pretty logical. If this giant memory cache is the bottleneck, let's just find some clever ways to shrink it down without making the AI dumber.
And engineers have come up with a whole bag of tricks to do exactly that. You've got things like grouped query attention, which lets different parts of the AI share a cache. Other methods compress the data, or even just forget the beginning of a long conversation to save space. It's all about making that short-term memory way, way more efficient.
And believe me, this isn't just theory. These tricks have a massive real-world impact. Just look at this example from the Llama 2 model. By implementing just one of these techniques, GQA, they almost doubled its speed. It went from about 1,200 tokens per second to 2,300. That is a huge performance gain.
Okay, shrinking the cache is smart. But what if there was a way to get a speed up without changing the model's architecture at all? This brings us to our second solution, a totally different approach that honestly feels like a cheat code. It's called speculative decoding.
The whole idea is built on one simple, beautiful insight that we already touched on. It is way, way faster for a big AI model to check a sentence that's already written than it is to painstakingly generate that same sentence one word at a time.
So here's how this cheat code works in practice. First, you have a small, speedy draft model. Think of it like a junior assistant. It races ahead and quickly writes a guess for the next few words. Then, the big, powerful target model, the senior editor, comes in and checks that entire guess all at once, in parallel. It instantly approves everything that's correct and only has to slow down and regenerate a single new word from where the first mistake was. You get the speed of the little guy with the guaranteed quality of the big boss. It's genius.
So these solutions are incredible optimizations, but at the end of the day, they're all trying to patch the fundamental limitations of the original transformer architecture that all these models are built on. So what's next? Well, the most radical solution is to just rewrite the rules of the game entirely.
And we're already seeing this happen. There are brand new architectures popping up, like state space models. Mamba is a great example. They were designed from day one to keep that memory cache at a fixed, tiny size. And then you have things like diffusion models, which just sidestep the word-by-word problem altogether. They basically generate a messy first draft of the entire response at once, and then refine it in parallel. This completely avoids that sequential bottleneck we've been talking about.
All of this points to a really fascinating shift happening in the AI world. This relentless pursuit of speed and efficiency is forcing a wave of incredible innovation. And it really leaves us with a provocative question to think about. Is the future of AI not about who can build the biggest model, but about who can build them smarter, leaner, and just fundamentally better from the ground up?